In this class, let us see the behavior of flat slab with a sketch. So here I have drawn a three-dimensional sketch of a flat slab. So A, B, C, D are the columns. So these four are the columns. So columns are represented like this. So I have divided this panel into 5 divisions here, 1, 2, 3, 4, 5 in either directions. So it may be square or it may be rectangular. Now here, how I have divided, you can see here. So the outer panel is called as the middle strip. These two, 1 and 5, they are called as the middle strip. Of course, continuity is there here. Please note that there is a continuity here. That is not the end. That this is not the last end. Okay, continuity is there in all the directions. I have taken only a panel. So here, this panel 2 and 4, where the column is present. Please note here, where the column is present, they are called as the column strips. So I have written the same thing in plan, 2-dimensional view here. This is the plan, this is 3D. So you can see here A, B, C, D. I have just treated like this. A, B, C, D, they are the columns, and spacing between the columns in this direction I have taken it as Lx, that is this distance AD is Lx, and in the other direction it is Ly. Spacing between AD. So this Lx will be equal to Ly if it is a square panel. Otherwise, if it is rectangular, it can be different. The condition is for a two-way slab, you know that this ratio Ly by Lx, longer span divided by shorter span, should be less than or equal to 2, or should be less than 2, you can take that. So this is the span. In the case of a, this is the ratio of the spans. In the case of a square panel, Ly by Lx will be equal to 1. So here, what happens, I have divided this into 5 divisions in both the directions. Among these 5 divisions, 1, 3, 5, they are called as the middle strips. 2 and 4, they are called as the column strips because they contain these panels, they contain the column. That is why they are called as column strips. So this is a column strip, this is a column strip, okay, this is a column strip, like this. The entire along the length. Okay, this is a column strip. So now this dimensioning is done like this. The distance between the columns, if you take in this direction as Lx. So the proportioning is done in like this. From here to here, it is Lx by 4. Then for this strip, it is Lx by 2. Then from this strip, it is Lx by 4. So if you add all these, the total equal to Lx. Similarly in this direction. So middle portion will have 50%. On either side, it is 25%. Now how this flat slab behaves, I have written in some points. Column strips, they are the broad strips of slab centered on column lines in 2 orthogonal directions. That's what I told her. So they are the broad strips of slab centered on columns. So these, what happens, these column strips, they are centered on columns. So this is a column strip. So this column strip is centered on column in 2 orthogonal directions, in this direction as well as in this direction. In both x and y directions, it is centered. Whereas middle strips, they don't pass through columns. So that's all. So if they don't pass through columns, that means there is no column here. In this, there is no column. So this can be taken as a middle strip. There is no column here. There is no column here. That's why I told 1, 3, 5, they are taken as middle strips. 2 and 4, they are taken as column strips. Column strips behave as continuous beams supported on columns. So this is how they behave. So even though there are no beams here in flat slabs, so the behavior is similar to beam slab column system. So that is general framed structural system. So deflections are slightly more. So slightly more than the rigid beam slab column system. So in a building we have, suppose we have beam slab column system. In the same building is designed as for a flat slab system, then deflection will be slightly more because I have told in advantages it is flexible. So flat slab system is more flexible than rigid beam slab column. So that is why the deflections are slightly more. If a system is flexible, deflections will be more. If the system is rigid, then definitely deflections will be less. So it's a comparison. So for the same structure, if it is a beam slab column structure, deflection is less. For a slab, flat slab, the deflection is more. But keeping all the other criteria, if you restrict the deflection within the maximum deflection limits, then flat slab will be economical. Column strip, see here, column strip AHD. So this is a column strip. So this column strip AHD, if I take for example, so negative bending moments will develop at A and B because A and B are supports. You know, in the design of continuous beam, at supports you have negative bending moment, that is hogging. Hogging bending moment will be there here. Whereas at the center, at the H is center here, where there is no supporter, or you can call it as mid span, it is going to have positive bending moment. So this is important when you are going to design, the reinforcement, because we are going to provide, you know that in the case of a slab, negative reinforcements are provided at the top, okay? Negative reinforcements, whereas positive reinforcements are provided at the bottom. That you know in the basic RCC design. Then coming to middle strip, so this is for column strip. Then coming to middle strip, UOG. So I have taken middle strip. So middle strip is the one which is not standing on a column. So columns are not there on the middle strip, EOG. So at all these 3 points, positive bending moment will be there. So when you are providing design reinforcement, you should take, that means at all these 3 points, at the ends as well as at the midpoint of the span, so positive moments will be there. Of course, we are using moment coefficients to calculate the moments. I will take up when I take up the design. Next, middle strips are supported by column strips. So this is important. So column strips, actually middle strips, what happens here, we are going to provide some drop or column head in the column strip only. So that is why the depth required at the column strip is slightly more than that required for the middle strip. So the behavior is these middle strips they are supported by column strips. Just like slabs are supported by beams, here these column strips act as beams. Middle strips are slabs, column strips act as beams, and column strips transfer the load to the columns. So that is the same general in a beam slab column system. The load transfer is like this, from slab to beam, then from beam to column. So similarly here, load whatever load is acting on the middle strip, it will be transferred to the column strip. From the column strip, it goes to the columns, and then from the columns to the footings. So this is how the load transfer mechanism is. And normally, since the loads coming on column strips are more, because middle strips also transfer the loads onto the column strips. So, and load will also be there on the column strips. So heavy loads will be there on column strips. So since heavy loads are there on the column strips, so bending moment will be high on the column strips compared to middle strips. Then reinforcement to be calculated for both the strips separately. Spacing to be decided based on the dia of the bar in the design, and we have to check for the punching shear also or the two-way shear also, because if it is, then we may have to revise the design. If the shear check is not satisfied, then you have to revise the design by providing a drop or a column head, or you can increase the thickness of the slab also. So you have to redesign that. So these are the some basic concepts of flat slab. So in the next class, I am going to take up the design aspect. Some 2 designs I am going to do. So let us take up that in the next class. For that you need that IS 456. I will give the classes which class you have to refer in the code page numbers. So based on that, you can easily design a flat slab with the drop or with the drop and what is column head, or with only drop. So whatever may be the case. So here, this one thing you should know that so loads carried by the column strips are more than the loads on the middle strips. So we have to take the moment coefficient. So that is called as redistribution of moment. So some moment factors we have to take, and we have to calculate the maximum bending moment on the column strip and middle strip separately. And for that moment, we have to design the reinforcement after checking for the depth provided. So I will take up the design in the next.